Hi everyone, I'm Emily and I will present our work on CASSIE, curve and surface sketching in immersive environments. First, let me give you some context about our work. Designers often go through two different steps when developing a concept. First, they explore ideas by loosely sketching on paper or with a pen tablet, or even with VR sketching. Then, they refine some of their ideas using 3D modeling software to produce surfaces suitable for rendering and rapid prototyping. In this two-step workflow, the first ideation sketches are often not reusable within the 3D modeling software, other than as visual inspiration or for manual tracing. For example, here the gray patches are created independently from the pink strokes, which are only used as a visual reference. In this context, our goal is to offer a common VR interface to perform these two steps using sketching as the prime interaction modality. So we present CASSIE, a VR sketching system where the user strokes are automatically knitted as she sketches to form a clean, well-connected armature. We additionally create surface patches, lofting the sketch by trying to automatically infer where the user wants a patch to appear. We also complement automatic detection with manual control with the option to add or delete a patch with a single click. The armature and surface patches make it possible for an artist to create a wide variety of 3D concept models by relying almost exclusively on sketching strokes as input. This system is composed of two separate components. First, we propose an automatic knitting scheme capable of structuring each input stroke on the fly to connect it to other strokes in the sketch, while minimally deforming the initial shape of the stroke. Secondly, we continuously analyze the armature created by the user to add surface patches to the sketch. I will provide some insight on how we do this, and you can find all the details in our paper. Knitting the input strokes is cast as an optimization problem where we set two objectives. Deform the strokes as little as possible to preserve user intent, while enforcing as many intersections as possible to get a well-connected armature. We select the appropriate subset of constraints to reach a balance of both objectives. Then we enforce those constraints on the stroke by optimizing the stroke control points. Creating the appropriate surface patches is done by maintaining a parallel graph data structure for the sketch. In this graph, the patches that we're looking for correspond to cycles, which are closed loops of nodes. So we launch local searches for relevant cycles whenever a stroke is added to the sketch or deleted. When a cycle is detected, we triangulate its boundary curve using the method of Toe and colleagues. We conducted a remote user study with 12 participants, half of which were amateur or professional artists familiar with VR sketching or sculpting, and the rest were novices, but all were familiar with using VR interfaces. We made them use three variants of our system. In freehand mode, users could sketch without any additional features. In armature mode, users would see their strokes knitted. And in patch mode, users would see stroke structuring and patch creation. We find that our novel features in the armature and patch systems are able to support users' creativity on par with freehand sketching. We further notice that the automatic creation of surface patches encourages the users to create well-connected armatures. Please refer to the paper for more user feedback. To conclude, we prototyped and tested a novel interface based on sketching in VR to create both sketches and surfaces, highlighting 3D sketching as an interaction mode for 3D concept modeling. We released the code for our Unity VR application and the full dataset, from all sketches done by users during the study, as well as all sketches showcased in the paper. We hope that these resources will foster exciting research in harnessing the power of 3D sketching in virtual reality. Thank you for your attention.